so today we're in section 6.6, scale drawings, learning about two different types of scales. One of them is a scale drawing, and that's two-dimensional. The other one is a scale model, which is three-dimensional. So a scale drawing would be like a blueprint on a house. A scale model could be something like the Statue of Liberty, the little model airplane, space shuttle. Those would be scale models. Okay, so the map in your book, we're all on page 300. The map in your book shows an ancient city of Teotihuacan. Okay, that's about as close as I can get to the pronunciation. And this is a large city built over 2,000 years ago, and the ruins of the city still exist in central Mexico. Do you see the picture on the bottom left corner of page 300? Do you guys see that picture? Okay, so the picture matches the map, all right? And the caption under the picture says that you are standing on the pyramid of the moon. This is a pyramid of the view of the pyramid of the sun. Do you see off to the left? There's another pyramid. That's the pyramid of the sun while you're standing on the pyramid of the moon. All right, so now look back over on your map. Do you see pyramid of the moon on the top? You see pyramid of the moon? Okay, so as you're looking out into the city, the pyramid of the sun would be to the left. So are you kind of visualizing that? All right, so that's how the two relate to each other. And now here's the catch. The scale of the drawing is 1 centimeter for every 200 meters. So 1 teeny little centimeter on the map stands for 2 football fields at an actual distance. And here's the question. It says on the map, again, okay, so now the pyramid of the sun is 4 centimeters from the center of the pyramid of the moon. What is the actual distance? Here's what it's saying. Visualize that you're standing in that picture, okay? Visualize that. Now, you're standing in that picture and you're looking off in the distance at the pyramid of the sun and you're saying, okay, I can't actually physically measure that. It's too far away to physically measure it, but I can use the scale of this drawing, and you're holding the map to figure out, okay, I know it's 4 centimeters away in the map, so I can figure out how far away it is in real life. Are you following me? I need to set up a proportion. So my proportion is the scale that it gives me, which is what? What's my scale? 1 centimeter over 200 meters. Write that down. 1 centimeter over 200 meters. So now 4 centimeters, again, it comes back to we've got to match up our proportions, the scale over the actual, or in this case you could say centimeters over meters, okay, but it's got to match up. All right, so you go 4 centimeters over, you don't know the actual distance, so that's why it's X meters, because you don't know. So now you can just solve the proportion like you would normally solve like any proportion. Okay? Okay, so choose the method that you want to use to solve. I did cross products and I got 800 meters equals X, because when I cross multiply 1 centimeter and X, I mean it's just X. All right, 1 times X is just X. So 800 meters is the actual distance. So again, standing on the pyramid, you're looking off to the distance. You can't measure the exact, but you can use the scale on your map that you're holding in your hand to figure out, okay, that's about 800 meters away. All right, so it's kind of that indirect measurement that we learned, I think it was 6.5, the last lesson. All right, so now I want you to take the same concept and solve this one. Okay, it says use the same map. So what does that mean? It means the same scale too. Okay, and the pyramid of the sun has a length and a width of 1.1 centimeters. So answer me this. If the length and the width are 1.1 centimeters, what shape is it?
Square.
It's a square. So that's why you only have to do one proportion. Because whatever it is when you plug in 1.1 centimeters, Whatever that answer is, that's what the width is too. Does that make sense? Whatever the length is, the width is going to be the same thing. So we don't have to do separate proportions. All right, so go ahead and plug in the numbers. Use your scale from the map. Plug in your numbers and figure out the length and width of the pyramid of the sun. All right, so setting up our proportion, we've got 1 centimeter over 200 meters equals 1.1 centimeters over don't know how many meters. Okay, so that's 220 meters by 220 meters because they are the same length and width, same dimensions. That's how large the pyramid of the sun is. Okay, so now in example 2, we're just going to shift gears a little bit. So in example 1, we were finding the actual distance. Now in example 2, we have actually that information, but now we're going to try to find the scale. So here in this example, all right, it says every few years the Grand Place in Brussels, Belgium is decorated with a large floral carpet made of begonias. So it's literally like a carpet that you would walk on, but it's made out of flowers. All right, so the designers, before they make this huge carpet that's 40 meters wide, they make a smaller scale, or they draw it up on a smaller scale, and the scale is 20 centimeters wide. So they give me the dimensions of the model, 20 centimeters, and they give me the dimensions of the actual carpet, which is 40 meters. Okay? You with me? So instead of trying to find one or the other, and I'm given the scale, now it gives me both of them. It gives me the dimensions of the model and the dimensions of the actual carpet, and now I need to find the scale. So here's a couple things that are really important. All right? It's very important that I show my label, okay? Because if I don't have a label here, I would think that it's the same unit, but it's not. There's a big difference between centimeters and meters. All right? The second thing is, in order for it to be written as a scale, my numerator has to be 1. So how could I make 20 into a 1? How could I reduce basically 20 to make it a 1? What would I have to divide by? Divide by 20. Okay? I need to divide by 20. And if I divide the top by 20, I have to do the same thing to the bottom. Divide the bottom by 20. So now, again, the label is important. It's 1 centimeter for every 2 meters. Okay? Again, if I drop my units, I'm going to think it's 1 to 2. But it's not. It's 1 centimeter for every 2 meters. That's the scale of this carpet drawing versus the carpet. You see how we figured that out? So in all of these, guys, and in all of your homework questions, it's going to be scale over actual. All right, you could even write that off to the side as that's your basis for setting up any of these ratios. It's scale over actual. That would be helpful to write down. Okay, scale over actual. That's how I set up these ratios. All right, you think you can do one? Okay, so find the scale. It's going to be the same scenario. Pretty much. To find the scale, you need to set up the scale over the actual and then reduce it so that your numerator is 1. It has to be 1 in order to be written as a scale, yes. Okay, so yes, so 15 centimeters over 75 meters. I divide top and bottom by what number? 15, and I get 1 centimeter over 5 meters. Okay, very good. All right, so that's it for example 2. Now we need to focus on writing. Not right now, okay. Now we need to focus on writing the scale. Okay, so you know how we talked about the writing the units important, otherwise I don't know what's being compared unless it's in the same unit, okay? So going back to the carpet example, the first carpet example, the scale was 1 centimeter to 2 meters, okay? 1 centimeter to 2 meters. So what they're saying is, if I don't want to write it with the unit, I can convert it to the same unit. All right, and here's what I want you to write in your notes. Convert the larger unit down to the smaller unit. Convert the larger unit down to the smaller unit. Okay, so in this case, is centimeters bigger or is meters bigger? Okay, meters is bigger. So I'm going to convert meters down to centimeters. And how many centimeters are in a meter? 100. So how many centimeters are in 2 meters? 200. So that's where I get 1 centimeter over 200 centimeters. And now that the unit is written in the same unit, top and bottom, I can drop it and just write the scale. Okay? Now, here's something else that's important to remember. If you see a scale that's written without the unit, it means that it is written in the same unit. Okay? So it's both feet, both inches, or whatever. All right? If it's not in the same unit, it has to be written labeling each one which one it is. Okay? So this is what it looks like as a question. You have 2 of these on your homework tonight. All right, so here's what it's going to look like. It's going to say, write the scale without the unit. Well, I can't just say 1 to 20. I can't just drop the units and say, okay, 1 to 20, because it's not in the same unit, so it's not the same comparison. I have to convert them to the same unit. All right, so you can either convert inches to feet, which is going to be a really small decimal, or you can convert feet to inches. Okay, all right, go ahead and try that. All right, so how many inches are in a foot? 12. So how many inches are in 20 feet? 240. So here's what I want you to write, guys. I need to see this second step, that you're clearly saying that 1 inch is compared to 240 inches, and then your answer drops the unit. 1 to 240. So I know that this is kind of backwards to the way that I've taught you all year, because it's inches to inches and then I drop the unit. But actually, if you write the unit in your answer, that's wrong, because the directions say to write the scale without the units. You cannot include the label. All right, and again, if you see a scale written without a label, it means it's written in the same unit. Okay? Now, number 2 is a little tricky, because you have to know how many centimeters are in a kilometer. So let me ask you this. What is the basis, the unit basis, like, that you would compare all of these other centimeters, kilometers, what would you compare them all to? You compare them all to 1 meter. Okay, that's what everything's being compared to. That's what everything centers around, is the 1 meter mark. So how many centimeters are in 1 meter? You have a problem just like this on your homework. Okay, 100 centimeters are in a meter. How many meters are in a kilometer? 1,000. So here's what you do. 100 times 1,000. What's 100 times 1,000? That's 10 times 1,000. It's 100,000. So if there are 100,000 centimeters in 1 kilometer, how many centimeters are in 5 kilometers? 500,000. Okay? Because there's 100 centimeters in a meter and 1,000 meters in a kilometer. You do 100 times 1,000, which is 100,000. That's 1. So then if you need to know how many are in 5, then it would be 500,000. And remember to write them without the unit. Okay? All right, you're going to do number 3 completely on your own. Write them without the unit. Write it without the unit. All right, so 36 inches in a yard, because 12 inches in a foot, and then 3 feet in a yard. So then 1 inch to every 180 inches, so 1 to 180. All right, who got that right? 1 to 180. Y'all kind of catching on? Catching on to this? Writing the scale without the unit. Now, one more example. Okay, and for example 3, all right, it says a model of a space shuttle has a scale of 1 to 52. The space shuttle has a wingspan of 78 feet. Find the model's wingspan. Well, here's the question I have. It says 1 to 52, but it doesn't tell me what if it's inches or feet or anything. So what does that mean if there's no label? Okay, what did you say? It means that they're the same unit. Okay, it means that they're the same unit. So 1 to 52, they're the same unit, but I don't know what unit it is, or does it tell me in some other part of the problem? What is it?
Inches.
Not inches, but feet. Because the space shuttle's wingspan is 78 feet, I know that everything is being compared in feet. Again, because the scale was written without units, I know that it's the same unit. So this goes back to example 1. My first ratio is my scale, 1 to 52. 1 to 52. And then on the other side, or again, it's scale over actual. We wrote that down. That's our basis. On the other side, I have to figure out, does 78 go in my numerator or denominator? It goes in the denominator, 78. And then W is what I'm solving for. And so now it's just cross products to solve. Okay? We've got 78 equals 52W. And then we solve for W. We divide both sides by 52 to get a wingspan of 1.5 feet. Okay? All right, you're going to do one, and then that'll be it. So I want you now to take the same scale. What's my scale? 1 to 52. And now I want you to solve if the space shuttle was 120 feet, 22 feet. Find now the length of the model. All right, so setting up our proportion, we've got 1 over 52 again. W over 122, divide both sides by 52, and we round to 2.3. And if you understand that, that's everything you need to know for section 6.6.